Welcome to the DIY Honda Garage channel. The DTC P2182-62 indicates a range or performance issue with the Engine Coolant Temperature (ECT) Sensor 2. This trouble code is recorded when the temperature reading from ECT Sensor 2 does not match the readings from ECT Sensor 1 and the Inlet Air Temperature (IAT) Sensor 1. The Powertrain Control Module, PCM, uses input from these sensors to regulate engine performance and temperature. If the data gathered does not correlate or falls outside the expected range, the PCM will trigger this DTC to alert technicians to a potential malfunction. Understanding the role of the sensors is crucial. The ECT sensors provide vital data on the coolant's temperature to optimize engine performance, preventing overheating or underheating situations. The PCM is typically located under the dash or in a specific area of the engine bay, depending on the model configuration. Thus, successful navigation of this code requires careful evaluation of all relevant components. The DTC P2182-62 is specifically linked to the Engine Coolant Temperature Sensor 2. This sensor plays a crucial role in measuring the temperature of the engine coolant, which is essential for optimal engine performance and fuel efficiency. It is connected to the Powertrain Control Module, PCM, which processes data from various sensors to make real-time adjustments to engine operations. The ECT Sensor 2 is commonly located near the engine block or radiator, where it can accurately measure coolant flow temperatures. When this sensor's readings are inappropriate compared to ECT Sensor 1 and IAT Sensor 1, it indicates an underlying issue that may affect engine performance. The inability of the PCM to receive accurate data can lead to engine overheating or suboptimal running conditions, hence the initiation of this trouble code. Multiple factors can contribute to triggering the DTC P2182-62. A faulty ECT Sensor 2 is often the primary suspect, as it may fail to provide accurate temperature readings to the PCM. This can result from internal malfunction or wear over time. Additionally, connector issues, including loose or corroded terminals connected to either ECT sensor, could interrupt the flow of critical data, leading to performance issues. Another cause could be a malfunctioning ECT Sensor 1, which may send incorrect information to the PCM, thereby affecting its ability to gauge the normal temperature range. Ultimately, pinpointing the exact cause requires methodical troubleshooting, focusing on each component in the circuit. Drivers may notice several symptoms associated with DTC P2182-62. One of the most concerning symptoms is engine overheating, as the PCM might fail to gauge the correct coolant temperature, leading to improper engine operation. This condition could be hazardous, potentially damaging engine components over time. Poor fuel efficiency is another common indication, as incorrect temperature readings can alter fuel-air mixtures and timing. Additionally, the PCM will store the specific trouble code, alerting the driver or technician to existing issues. These symptoms make it imperative to diagnose any abnormal data from the ECT sensors promptly to maintain engine performance. The first step in troubleshooting DTC P2182-62 involves turning the vehicle to the off lock mode and allowing it to remain idle for a minimum of 6 hours. This waiting period is essential because it ensures that all sensors cool down, allowing for more accurate performance readings. After waiting, the technician should start the engine and let it idle for at least 10 seconds. This brief idling period enables the PCM to receive temperature data from both ECT sensors and analyze any abnormalities between them. The information gathered during this process will provide baseline readings to determine if further investigation is necessary. The next troubleshooting step entails a thorough visual inspection of the connectors associated with ECT Sensor 1 and ECT Sensor 2. Ensure each connector is securely attached and check for any loose terminals that could influence the reliability of the data sent to the PCM. These connections play a pivotal role in ensuring that accurate temperature readings are transmitted to the control module. If the visual inspection reveals any abnormalities or loose connections, repairing or replacing them may resolve the error. A good practice is to carefully check for signs of corrosion or wear, as compromised connections can lead to erratic sensor performance. In this step, start the engine and let it idle for approximately 10 minutes. This duration allows the engine to reach its normal operating temperature and enables the PCM to collect consistent readings. Next, use the Honda Diagnostic System, HDS, to check the value for ECT Sensor 1. According to normal conditions, the value should exceed 120 degrees Fahrenheit, 49 degrees Celsius. If the reading is lower than this threshold, it indicates a malfunctioning ECT Sensor 1, which may require further inspection or replacement. Monitoring real-time data helps technicians pinpoint issues promptly and effectively. For this step, allow ECT Sensor 1 to cool down to ambient temperature, ensuring a more accurate assessment. Once cooled, note the surrounding ambient temperature to use as a benchmark for comparison. Then, switch the vehicle to the on mode without starting the engine. Quickly access the HDS to check the ECT Sensor 1 reading. Under normal conditions, the difference between the HDS value and the recorded ambient temperature should be less than 5.4 degrees Fahrenheit, 3 degrees Celsius. If the difference exceeds this limit, it indicates that ECT Sensor 1 is likely defective and will need to be further evaluated or replaced to resolve the DTC P2182-62 issue. Another critical step involves restarting the engine and allowing it to idle for 10 minutes, mirroring the previous diagnostic steps. This allows the system to reach operational temperatures, providing a significant amount of data regarding sensor performance. Utilize the HDS to confirm the reading for ECT Sensor 2. The normal operating condition should also reveal a value that exceeds 120 degrees Fahrenheit, 49 degrees Celsius. If it falls short of this value, then ECT Sensor 2 may be faulty and further investigation is warranted. Ensuring accurate readings from both coolant temperature sensors is integral for maintaining optimal engine performance. Suppose after testing ECT Sensor 2, it is necessary to allow it to cool down to ambient temperature. This method is important in order to measure its performance accurately. As with ECT Sensor 1, note the ambient temperature and switch the vehicle to the on mode without starting the engine. Use the HDS to promptly check the ECT Sensor 2 reading. Under normal conditions, the difference must be less than 5.4 degrees Fahrenheit, 3 degrees Celsius from the ambient temperature. If this difference is greater, it indicates a malfunction in ECT Sensor 2, suggesting that it may need replacement or further inspection. These methodical checks help in isolating the cause of DTC P2182-62. After performing necessary repairs, it is crucial to verify that the DTC P2182-62 has been resolved. Begin by clearing all stored DTC codes using the HDS. Once cleared, conduct a test drive to allow the PCM to gather fresh data from both ECT sensors during normal engine operation. Carefully monitor the performance and ensure that no new codes are triggered. A successful resolution will mean that the vehicle operates efficiently and no checks occur on the dashboard indicating engine troubles. This final verification step solidifies that any underlying issues have been effectively addressed. Preventive maintenance is vital in ensuring long-term reliability regarding DTC P2182-62 and similar issues stemming from sensor malfunctions. Regular checks should be performed on ECT sensors and relevant connectors to ensure no wear or degradation develops over time. Also, maintaining connector cleanliness is essential. Dirt and corrosion can interrupt data flow and lead to erroneous readings. Additionally, consider integrating periodic system diagnostics through the HDS to catch potential issues before they escalate. Establishing a maintenance routine can help in preventing engine cooling performance problems, ensuring optimal thermal management. In conclusion, DTC P2182-62 points towards significant abnormalities with the Engine Coolant Temperature Sensor 2 circuit performance. Symptoms such as engine overheating and poor fuel efficiency make it imperative to address these issues promptly. Following the structured troubleshooting steps ensures a systematic approach to accurately diagnosing the situation and clarifying sensor status. Regular maintenance checks on both sensors and their connections can significantly minimize the likelihood of this trouble code appearing in the future. It is crucial to ensure the PCM receives accurate data, contributing to the efficient operation of the Honda CR-V engine. Please like and subscribe to the channel. See you next time.